Hi. Another paper for projectile chapter. Okay, this is June 2013 R paper. Okay, because there are two papers unit one. One is R and one is normal. They're both the same in terms of syllabus. So this R paper from June 2013. It's there in the files which I'll be giving you guys once you guys come here. Okay. Now the photograph shows an athletic performing a long jump. Okay, can you see it's a typical projectile motion. It's a typical projectile motion. It just goes up, reaches the maximum point, then it comes down and hits the ground. Okay, so this is the whole thing. Now they said that at takeoff the horizontal speed is 8 meter per second. So the horizontal speed is 8 meter per second and the vertical speed is 2.8 meter per second. The vertical speed is 2.8 meter per second. Okay, so yeah, so this is the how the projectile will be going. Okay, this is the takeoff. If we do Pythagoras theorem, we will get the actual velocity at which the person took off. Okay, so all horizontal and vertical velocity has been given to us. Usually the angle is given and we have to do sin theta and cos theta. In this case, that's not the case. Okay, show that the total time athlete spends in the air is 0.6 seconds. While teaching projectile, I actually mentioned that the time taken to go up is and reaches the maximum point is equals to the time taken to come down. Okay, so and also if you drop something from the same height, it takes time t to reach to the ground. If you drop something from the same height, it maximum height, it takes time t, and if you multiply that time by 2, that is the total time for the whole journey. Basically to go from here to here takes the same time when you drop something to the ground. So if you drop something to the ground, okay, and if you throw something horizontally like this, for example, they both take the same time to the ground to reach the ground. This you are supposed to remember. So the total time of the journey is the time taken to reach from here, from the maximum point to the ground, multiplied by 2. Remember this. Okay, and I hope you guys understood. If you didn't, please do ask me in the class. Okay, so again I'm repeating, the time when you throw something from here horizontally and when you throw something vertically, they both reach the ground at the same time, and if you multiply that time by 2, that gives you the total time of the whole projectile motion. Okay, so in this case vertical velocity has been given to you. So we know the initial vertical velocity because its initial vertical velocity is 2.8. So initial vertical velocity is 2.8 meter per second. Okay, final velocity is 0. To be honest, when you throw something from here to here or when you throw something from here to there, at the end of the day the time is same. Okay, so I'm assuming I'm throwing something from here to there, so maximum velocity is what? 0. Vertical velocity is what at maximum point? 0. So v is equal to 0. What's your acceleration? It's going up, so acceleration is minus 9.81. What do we want? We want time, question mark. Okay, which formula? V equals to u plus at. V equals to u plus at. V is 0, u is 2.8. Okay, minus 9.81 into time, that is question mark. Okay, we don't know, so bring this on the other side. Minus 2.8 divided by minus 9.81 is equal to time. Let's see in the calculation how much we are getting. 2.8 divided by 9.81, the minus gets cancelled. It's 0.285. It's 0.285 seconds. I told you the total time of the journey is double of that. Okay, the total time of the journey is double of that. How much is it? 0.285 into 2, that is 0.57, close to 0.6 seconds. Okay, I hope first part you understood with this explanation. Then they said, calculate the horizontal distance jumped by the athlete. Whenever they speak about horizontal distance, please use this formula. S equals to horizontal velocity into time. So S equals to horizontal velocity. How much was horizontal velocity given to us? 8 meter per second. So 8 into how much second was it traveling for? Exactly the whole journey distance. Exactly the whole vertical journey. Vertical journey and horizontal journey times are in projectile all is same always. So how much? 8 horizontal? Yes, confirm. 8 into multiply by 8, so I'm getting 4.56 meter. He went around 4.56 meter, so that's his answer for B part. Now comes the most tricky question for 4 marks. Okay, in reality, when the athlete lands, the center of gravity is 50 centimeter lower. So basically, when you're making that jump, when it's coming over here, when he's coming to the ground, his center of gravity was here. Now his center of gravity is actually 50 centimeter less. That means his S is not 0, not anymore. Because since the center of gravity has shifted, so does his final displacement. Now the final displacement is minus 50 divided by 100. I'm converting this to meter, okay? Why minus? Because it came back to its original position. The person returned back to its original position, but the center of gravity is actually 50 centimeter lower than that. So that means our displacement measure starts from center of gravity. So center of gravity has 50 centimeter lower than its initial position. If the center of gravity was over here, S was 0, but now it is below 50 centimeter. 50 divided by 100, how much is it? Minus 0.5 meter. So minus 0.5 meter. Okay, so what's my S? S, and what did they say? Calculate the extra horizontal distance. Now the thing is that he traveled that extra time. What is that extra time he traveled for? Let me find that first of all. S how much? Minus 0.5. Whenever we talk about this height, we always talk about vertical displacement. And in vertical displacement, we always take vertical velocity, not horizontal velocity. Vertical velocity. Horizontal velocity has its own equation, this. Okay, and we are talking about vertical displacement here. Look, vertical displacement is increasing, max, decreasing, 0, 50 centimeter below, that is minus 0.5 meter. Okay, acceleration is going up, right? So minus 9.81 initially. Okay, now what's your vertical velocity? It was 2.8. Okay, what is the time? Question mark. Let's find it. Okay, what's my initial velocity? 2.8. Okay, now can we do S equals to ut plus half at square over here? Because I don't know what was the final velocity here. I only know the initial vertical velocity. Okay, I can't even do double the time because it did not travel the same distance right now, because it has traveled this extra distance. So they both are now not, the left hand side and right hand side are not equal to each other now. So the right hand side is more, the right hand side displacement is more. Okay, so this is the only equation that is I've been left with. Any other equation can I use? No. To make it more easier, none. So S equals to ut plus half at square minus 0.5 is equal to ut 2.8t minus half a t square. Okay, so let's all bring it together later on. I can do this in calculator. Actually, usually maybe you need to do, if it was a maths, you would have done minus b plus minus root of b square minus 4ac. What I would do to save time, I will do it in a calculator. You guys can try with that. Okay, I'll show you which is a, b and c. So 2.8t minus 9.8 divided by 2, how much is it? 4.9t square minus 4.9t square. You see, bring everything together to make it positive, your t square positive. So if I do that, 4.9t square minus 2.8t minus 0.5 equals to 0. Let's do this in calculator. I have the calculator, I'm doing it. I'm pretty sure most of you know how to do quadratic equation in your calculators. Equation, you know what? Let me do in calculator as well. Let me just project the calculator, that would be better for me. Okay, so I got the calculator here. Let's choose equation 5. Let's do third one. It's third one? Yeah, it is third one. Okay, how much is it? A is 4.9. Okay, B is minus 2.8. Okay, C is minus 0.5. Okay, so you end up getting negative time. We don't take, time cannot be negative. So 5 by 7. How much is it? 5 by 7 in calculator? It's 0.714. Okay, so your time is 0.714 seconds. What was the time we got before? It was 0.57. So the extra time he has traveled was, extra time because of that is 0.714 minus 0.57. So minus 0.57, that's around 0.144 seconds. 0.144 seconds he has traveled extra. Now, because of the extra, he has traveled some extra horizontal distance. But remember, horizontal velocity did not change. Horizontal velocity is still 8 meter per second. And he has traveled this extra distance, extra time. So can we do, I'm doing it in some different color. Okay, so that you guys don't get confused. Okay, let me do what horizontal velocity now. Okay, s equals to uh into t. So extra distance is 0.144 into the time. You're in exam, you're not supposed to write it this area. Okay, remember that. 0.144 into how much is it? 8. 0.144 into 8. If I multiply, he has traveled 1.15 meter extra. I'll not check the mark scheme, okay? And let me see whether it matches. And if you see the mark scheme, okay, if you see the mark scheme, that is the answer. You see, the extra horizontal distance has been around 1.1 to 1.1 to 1.2. So I got 1.15, which is within the range 1.2. Okay, I hope you guys understood. Okay, tata.